Paul Stamets, what?
He's
Is a real person.
Welcome to a very special bonus episode of our Star Trek Discovery Recap FREQcast. Hey, Ebony, guess what?
Anita, what?
We've never done a bonus episode because there's never been really a reason to, but
In honor of the last episode, we're going to blow our listeners' minds. Is that what you're going to tell me?
Yes, we are.
So
And you want to
glad.
know why?
Tell me.
Because I was at the Canadian game studio BioWare a few weeks back, and I was talking to some folks, and this woman came up to me, and she was like, hey, I've been really enjoying your Star Trek Discovery podcast, but, like, my problems with it are different than your problems with it. But we all got problems with it. And I was like, what? And she's like, look, I have a degree in mycology. And I was like, oh, my God, that's a real thing.
What a wonderful person to have run into.
I know. And I immediately, before she said anything else, was like, will you be a guest? Will you come tell us all of the sciencey
Yes.
things?
Yes.
So she is a delight. Her name is Emily Taylor. She has a bachelor's degree of science and a master's degree of science in plant pathology, which is plant diseases specializing in mycology. Those are probably words that people
She sounds like a
understand.
total brain box.
Yeah, and now she works in game development. So
What?
fascinating.
Yeah.
She did us this amazing favor and recorded a whole little, like, I think it's about 16 minutes about all of the things wrong with the science of well, not all, but many of the things wrong with
Yeah,
it.
she
So-
couldn't get through it in one bonus episode, but holy shit. Can we listen to it?
Yeah, let's roll it.
Hi, Anita. Hi, Ebony. Hi, 3 podcast subscribers. Okay, so Anita suggested I call in and take a few moments to discuss all of the things wrong with the science of discovery. Unfortunately, I am here to tell you that there just isn't enough time in the day for me to cover all the things wrong with the science in the show. Instead, I'm going to have to focus on just my biggest pet peeve, which is the biology. I do actually work in another field these days, but I have 2 degrees specializing in mycology, and let me tell you, this show talking about the spore drive makes Hollywood talking about hackers look good. So, hold on to your seats when big mushroom rant is incoming. So Star Trek is a science fiction show, yes. But the show's not about the science, it's about the people, and the Federation, and the optimism for the future of humanity. What the original writers did really well is to come up with terms that sound sciencey, but aren't really real things. Keeping the details of the science vague not only kept the focus of the show where it belongs, on the people, but also helped the show age more gracefully. For example, using the word phasers instead of lasers. The audience in the 1960s might not have known very much about what lasers can or can't do. But 50 years later, when we have laser pointers and laser printers and everything, the original show would sound pretty silly to us now if they'd decided to use laser guns instead of phasers. Throughout the different Star Trek series over the years, the writers have more or less stayed vague enough on most of the science that the audience can suspend disbelief and just enjoy the story. So let's start by talking about Ebony's favorite character, astromycologist Paul Stamets, and his quest to develop an alternative to the warp drive. There's any number of made-up words the Discovery writers could have used to describe some new type of transport drive without really going into any kind of scientific detail. Unfortunately, they didn't use any of them. Instead, they watched a 2008 TED Talk by a guy called Paul Stamets. Sound familiar? Yes. Anthony Rapp's character on Discovery is actually named after him. The real-life Paul Stamets is pretty much a self-taught mycologist, which means someone who studies fungi. So when we talk about fungi, which includes the mushrooms we can eat and the yeast that makes alcohol and bread for us, we're actually talking about one of the kingdoms that we use to classify life on Earth. Animals, including humans, are in one kingdom, the animal kingdom. Plants are in another kingdom, the plant kingdom. And fungi, they're in a completely different kingdom from both of those. Although we think about mushrooms when we think of fungi, mushrooms are really more like the flower of a much larger fungus that's mostly underground, often forming a huge underground network of tiny little filaments, like little roots that spread out to gather as much food as possible from as wide an area as possible. Most experts think fungi are a bit more closely related to us than to plants. Like us, they breathe oxygen and produce carbon dioxide, and they can't photosynthesize the way plants do. However, like plants, they don't get up and walk around, and they often grow in the soil. Because they don't photosynthesize, but they also can't run around and chase down their food, fungi have become really, really good at extracting nutrients from the soil or from other decaying things like compost or dead animals. So the real-world Paul Stamets' TED Talk was about how fungi could be used to clean up pollution, such as oil spills or industrial runoff. Because they're so very efficient at eating pretty much anything available, It means there are some species that have even learned to eat chemicals that are pretty toxic to most other things. They also have to be pretty competitive because they're fighting for food with other things in the soil like insects and bacteria that might want to eat the same things. In order to win those fights, different species of fungi learn to fight off their competition in different ways, which is why we get things like antibiotics from certain types of fungi that have spent a lot of time fighting for food with bacteria, so they learn to create substances that would kill bacteria. Other fungi have found ways to kill certain types of insects, and some fungi have found a way to make a kind of symbiotic partnership with certain types of plants. In this case, the plants give the fungi some of the food they can make using photosynthesis, and in exchange the fungi provide nutrients they find in the soil that the plants might not be able to reach themselves. Fungi are all over the place and all through the soil, and because it's a pretty competitive place down there, they've developed some pretty creative ways to find food. In his TED Talk, Stamets has pointed out a lot of ways that humans can find that very useful, from fighting diseases to cleaning up pollution.
Spore drive is online. Plot destination for Corvan 2. At your pleasure, Captain.
So let's get back to Star Trek Discovery. Starting in the third episode, Context is for Kings, the jargon starts getting thrown around thick and fast. We learn that the show's version of Paul Stamets is growing spores, which apparently allow the ship to travel. So what's a spore? The word spore literally comes from the Greek word for seed. It just means a single-celled seed that can grow another organism, but is produced asexually. In other words, the fungus doesn't need a second fungus, it just buds off a little bit of itself to form a seed. It's kind of weird that the spores on Discovery are blue and glowy and big enough to see floating around, and it's also weird that the fungus they grow on looks more like bushes than mushrooms, but whatever, it's still a fungus seed.
And you talk about spores. What are they? They are the progenitors of panspermia. They are the building blocks of energy across the universe.
What does progenitors of panspermia mean? Well, a progenitor is just an ancestor or parent, something from which other things are descended. Your grandparents are your progenitors, for example. Panspermia is a theory from the 19th century that hypothesized life on Earth could have originated from microorganisms or some other kind of chemical precursor of life that came in from outer space. It's just a theory and there's no proof if it's true or not, but let's imagine in Star Trek's time, maybe they have managed to prove life on other worlds did originate in some common ancestor. So could fungal spores have been the distant ancestors that spread life to Earth? Well, almost certainly not. Our fossil record shows that it was a long time before anything resembling a fungus showed up on Earth. There were lots of earlier forms of life before fungi turned up, so if there was an early ancestor that seeded life on Earth, it wasn't a fungal spore.
Mycelium spores, harmless, harvested from the fungal species Prototaxidus stellaviatori, which we grow in our cultivation bay.
Lorca specifically says the fungus is called Prototaxides. If the writers had wanted to cover their bases, they would have completely made up a name like phasers, and maybe also not called it a fungus, so we could just assume it's some kind of advanced space organism we don't know about yet. Unfortunately, they didn't do that. They decided to use a name of a fungus that exists. So what is Prototaxides? It's a real name for a genus of fossil found from about 400 million years ago. It literally means first yew, because the fossils look a bit like yew trees. They were about 3 feet wide and over 20 feet tall, which probably makes them the tallest thing growing on land at that time. Until about 2007, no one was even sure if Prototaxides was a tree or a lichen or what, but nowadays there's quite a few researchers who believe it's most likely related to a fungus of some sort. The big tree trunk-like structures were probably the mushrooms that produced the spores, and the main body of Prototaxides would have spread out underground. Star Trek Discovery has given its version of Prototaxides a species name, which they pronounce slightly differently in the different episodes, but it sounds something like stellaviatori. This is just a made-up word based on the Latin for star, stella, and for traveler, viator. As far as anyone has found, however, all species of Prototaxides on Earth are completely extinct and have been for probably hundreds of millions of years.
You see the etchings on the hull? It's evidence of catastrophic basidiosac rupture.
Basidiosac. That's an unfamiliar term.
Also in Context is for Kings, the Discovery investigates the damage done to the Glenn, the other ship that was studying the spore drive. Stamets exclaimed that there are etchings on the hull caused by catastrophic basidiosac rupture. So what exactly does that mean? Okay, so basidiosac is also a made-up word, but it's based on a type of fungal spore called a basidiospore. Presumably, we're supposed to think a basidiosac is a structure that holds basidiospores, which can rupture and cause damage to the USS Glenn when it burst. Unfortunately, basidiospores are a very technical term for a specific type of spore that's only produced by certain types of fungus in the group Basidiomycota, which almost certainly doesn't include prototaxides. So saying that prototaxides produced basidiospores would be kind of the same as saying that a tulip plant produced pine cones. Yes, they are both plants, but it doesn't actually make the slightest bit of sense. So let's just ignore this one entirely and pretend the writers weren't just randomly Googling fungus-related words and putting them into the script without any idea what they mean.
All right, let's start with our mushroom, Prototaxites stellaviatori, a species made up of exotic material found not only in normal space, but in a discrete subspace domain known as the mycelial network. Its fungal roots, aka mycelium, spread across the universe, fanning out into infinity to create a matrix that serves as our intergalactic freeway system.
Lieutenant Stamets explains that the fungus is found not only in normal space, but also in a discrete subspace domain known as the mycelial network. He says its fungal roots, known as the mycelium, spread across the universe, fanning out into infinity, blah, 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 blah. Okay, so what is all that in English? First of all, mycelium is just a fancy name for the network of tiny fungal roots that is not the mushroom part of a fungus. It's basically the flesh or the body of the fungus. It's the part that isn't making spores. A mycelial network is just the root-like structure that hundreds and thousands of little fungal roots form when they grow through the soil. If you've ever lifted up a rotting log in the forest and noticed a very fine white thread-like web connecting it to the ground, you've probably seen a mycelial network. It has a fancy-sounding name, but it's not some kind of magic invisible thing. You can see it, you can touch it. Based on the fossils of prototaxides, the tiny tubes forming their mycelium would be about the size of a very fine human hair or slightly smaller, but would be visible to the human eye, especially if there were a lot of them forming a network. Clearly, there are no mycelial roots growing through the air or in outer space, and if there were, it would be like walking through spiderwebs. Mycelium is a physical thing. Saying there's a mycelial network connecting everything in the universe is like saying there are invisible magic tree roots connecting everything across space and time, which is obviously ridiculous to imagine, whether or not it's in normal space or in some kind of special alternate dimension. But let's imagine there's some kind of invisible magical mycelial network that we can somehow walk through that doesn't freeze and die in outer space and somehow doesn't get broken as planets rotate in orbit and doesn't burn up in the sun. Even if this network exists, how does a starship use it to travel?
How do you travel on spores?
Imagine a microscopic web that spans the entire cosmos, an intergalactic ecosystem, an infinite number of roads leading everywhere.
The veins and muscles that hold our galaxies together.
The real-world Paul Stamets talks about how fungal mycelium can transport many times its own mass in nutrient molecules and water across its network. The large overall mass of mycelium can transport a lot of water, but it's still passing through tiny tubes. This uses normal physics and chemistry and happens at normal speeds, like the way plant roots absorb water and transport it from the roots to the leaves. The show mentions the mycelium existing in alternate dimensions, so presumably the show wants us to believe that this creates shortcuts across that allow direct travel between any 2 points where the mycelium exists, which is apparently everywhere. Even so, however, there's no explanation of how a large object could be transported through what's described as a microscopic web, unless it was first dissolved into small enough liquid molecules to be distributed through the mycelial tubes. This would obviously cause some serious problems for a starship and its inhabitants, which would have to fit through tubes the diameter of human hair and would be liquid when they arrived at the other end.
Let's call it Ripper. It's what it looks like. It's what it does.
Your Ripper appears to share some natural traits with the tardigrade species, a docile creature that lives in the waters of the Earth, a microanimal, capable of surviving extreme heat and sub-freezing temperatures.
Finally, let's talk tardigrades. Tardigrades are pretty cool creatures. They're real things discovered in 1773 by a German zoologist, and they've been found practically everywhere in the world. They're microscopic-sized, 8-legged critters, and they actually look pretty much like the creature called Ripper on Discovery, except that on Earth they're only about 1 millimeter long at most. Tardigrade means slow walker, and they're also called water bears because their walking gait is similar to a bear's. They're super resistant to all sorts of hostile environments, even including the vacuum of space, and they've survived 5 mass extinctions in Earth's history. They'll probably outlive cockroaches.
The creature has gone into a state of extreme cryptobiosis by reducing the water content levels of its body to less than 1%. Its vital signs have slowed to the point we can barely detect them.
In Discovery, Ripper is described as a cousin of Earth's tardigrades, and eventually he becomes unhappy on the ship and goes into a state of cryptobiosis. This is a real thing too. In a hostile environment, tardigrades basically shut down their metabolism and go into a kind of hibernation until things get better, even if that doesn't happen for years. So apart from its size, Ripper does seem pretty similar to Earth's real tardigrades.
Enter the tardigrade, whose unique genetic makeup allows it to navigate through the network because of its symbiotic relationship with the Mycelium's spores. Like its microscopic cousins on Earth, the tardigrade is able to incorporate foreign DNA into its own genome via horizontal gene transfer. When Ripper borrows DNA from the Mycelium, he's granted an all-access travel pass.
In the quote we just heard from Choose Your Pain, Michael discusses how the tardigrade uses horizontal gene transfer. There's so many things wrong with this that I don't know the best place to begin. But first of all, yes, horizontal gene transfer is a real thing. So is vertical gene transfer. Vertical gene transfer is the way genes are passed down from parent to child. You have the genes of the people above you in your family tree, and you pass them down to the children below you in your family tree. Vertical. So horizontal gene transfer means passing genes sideways to other people, not through the vertical family inheritance structure. For example, when people talk about gene therapy to correct genetic diseases, that would be horizontal gene transfer. You're taking healthy DNA and editing it into the DNA of the person with the disease to fix it. Now, it doesn't make a lot of sense why Ripper would need to have space fungus DNA, since the show already said they have a symbiotic relationship that would presumably let them work together already. But theoretically, let's say the mycelial spores have some weird ability to visualize a complete map of where all of the mycelium in all of the universes is right now. If that ability is a part of the fungus's DNA, okay, that's also dubious, then if Ripper were able to add that DNA into his own, he might be able to acquire the same ability, which explains why Ripper is able to visualize the mycelial network. Okay, so we can maybe sort of justify why Ripper needs the spores at least once anyway. It still doesn't explain how Ripper could actually travel that network, let alone how it could take the ship with it, but okay, whatever. The bigger problem is that tardigrades don't actually have the ability to perform horizontal gene transfer that Michael says they do. There was one research paper in 2015 that suggested they did, but this was rapidly disproved within months by multiple other researchers who showed the study had just been using contaminated samples. There's no animal capable of horizontal gene transfer, and definitely not tardigrades, and this was very clearly accepted long before the Discovery writers sat down to write these scripts. So to sum up, here's my big problem with Discovery. First, it's just generally a bad idea for a show like this to refer to modern-day science in any kind of detail, even if you're 100% accurate, because our knowledge about the world is changing so fast that in just a few years, whatever you wrote may sound completely ridiculous and out of date. Using sciencey-sounding words like phasers and dilithium crystals helps you avoid that problem. But second, and most of all, if you absolutely insist on ignoring point number one and using actual real science words and theories, for goodness sake, actually get a science consultant and make sure you're not talking complete crap that makes the show sound idiotic. Using believable but vague future science is best. Using real and accurate current science is second best. Googling random real science words and using them to sound like Gwyneth Paltrow selling goop not only makes the show's science laughable, but also detracts from the actual message of the show. In the 14 episodes so far, we haven't even had time yet to meet the bridge crew, yet we've had to listen to so much exposition about fake science that's completely incoherent that I'm tired of even hearing the word mycelium, and I spent years studying it. I don't want this show to be about a bunch of writers who watch one TED Talk showing off their fake science theories. I want this show to be about exploring the universe, meeting alien races, and getting to know the people who'll form the Starfleet of Kirk and Spock's time. That's the reason I fell in love with Star Trek in the original series, and that's the reason I was so excited to watch Star Trek Discovery this year. And that's the reason a little bit of my heart dies every time I watch another episode and hear expositions about complete bullshit science instead of actual plot and character development. Well, I could continue for a lot longer, but I do have a real job to get back to, so I'll have to end this rant here. I hope that at least I've given you an idea of how interesting fungi really are in their own right, without needing a science fiction show to invent crazy things about them. And if you stuck with me this far, I hope that maybe you now agree with that too.
Well, my mind is blown. I knew there were a lot of things wrong with Star Trek Discovery, but I just had kind of a loose, non-scientific understanding of what was wrong with it. I just feel like I took a graduate course in mycology.
Right?
Also, Paul Stamets, what?
He's
is a real person. Jinx. Anita owes me a Coke. That is the most mind-blowingest part of this
What do
for
you
me.
think he's like? Oh, we should watch the TED Talk just to be like, are you actually modeled off of? Like,
I want to know what he thinks about Discovery now. Like, is he
Right?
salty about it, or is he
I
like,
hope so.
I hope they're either throwing that dude some coins, or they're gonna let him be like in the background of a scene or something. They can't just like straight up,
They just took his name.
Yeah.
Man, I wonder what the deal is there. Or maybe he's just like so excited to be like represented that he doesn't care that
I'm
the
not
science
gonna lie.
is bad.
I'm not gonna lie. If it was me, even with the problems this show has, I would put that on my business card. So, wow.
Yeah.
But also, phasers, lasers. That is such a good point.
Yeah.
right?
That was one thing that really stuck out to me is I'm like, oh, so she's talking about how using sciencey like words is so much safer because it gives you that cover.
Right.
And I didn't ever think about it. And so for her to be like, why didn't you just fake it and like make up all these fake words that are sort of tangentially related?
Right.
Yeah. Why didn't you?
Yeah, which obviously would have been easier because clearly no one on that writing staff was comes with a like hardcore science background or was going to do the research to actually, accurately portray this stuff. So, yeah, make stuff up. That's what I do in my life.
But here's the thing too is that like how many people in the world know that the science is wrong? Right?
Emily
like do
knew.
they well, totally. So maybe there's like a handful of people who are like this shit is wrong. And I guess the creators are just like and the writers are like, "Well, we'll take that risk."
I bet that there are people like Emily on mushroom message boards across the world pissed off. And I just want to know, y'all, you have my sword. I'm ready to storm the gates with you because I feel like I learned something.
All right, so big thank you to Emily for doing that for us. That was such a treat. And maybe we'll have you on again when we resume in season 2 because we're going to do that. Be sure to subscribe anywhere that you get your podcasts so that you know when season 2 starts again because we will be right here to bring all the salty hate.
Oh, I cannot wait. Y'all.
And then we don't get our Sundays. And I'm so excited about having our Sundays back.
Who you telling? I can't wait.
Check out feministfrequency.com for all our other podcasts and videos and articles. And if you love what we're doing, please consider donating. You can visit feministfrequency.com/donate. Bye.
Bye.